Hello everyone, I am Dr. Godandaraman. In this section we are going to discuss with vector calculus MCQ question. MCQ is nothing but multiple choice question. See the problem. Pi value is given x, y, z, del pi to find. So del pi is nothing but what is the del I vector dou by dou x plus j vector dou by dou y plus k vector dou by dou z. Dou is nothing but partial derivative into pi x, y, z. Now multiply inside this bracket I into dou by dou x of x, y, z plus j into dou by dou y of x, y, z plus k into dou by dou z of x, y, z. When we are differentiating partially with respect to the first term x, so x only variable, y is a variable, z is the variable, other value consider constant. Now I vector when x differentiation 1, y z plus j vector when y differentiation, so x constant, y differentiation 1 z plus k vector x y constant z differentiation 1. Therefore here y z I vector plus x z j vector plus x y k vector. Now see the option is A, y z I vector, z x j vector, x y k vector. And then next, directional derivative pi given at the point 1, 2, 3 along x axis. Now the directional derivative is nothing but del pi dot a vector divided by a vector modulus. Now first to find del pi. Del is I into dou by dou x plus j into dou by dou y plus k into dou by dou z into x y, y z, z x. So when we are multiplying inside this one, dou by dou x of x y, y z, z x plus j vector dou by dou y of x y, y z, z x plus k vector dou by dou z of x y, y z, z x. When I am differentiating with respect to x, this is the x means x only the variable, other value constant, y variable, other value constant, z variable, other value constant. Therefore when I am differentiating I vector x 1 y plus y z constant 0 z x differentiation 1 plus j vector, here y partial derivative, x constant, y differentiation 1, y differentiation 1 z plus 0 plus k vector x y constant 0, y into 1 plus 1 into x. Now this is a del pi. So substitute del pi at the point 1, 2, 3 point. So 1 is x, 2 is y and 3 is z. Therefore I vector y 2 z 3, so 2 plus 3 plus j vector x value 1, z value 3 plus k vector y value 2, x value 1. Therefore 5 I vector, 4 j vector, 3 k vector. Then a vector is x axis. X axis means only I vector 1 0 0. Therefore I vector plus 0 j vector plus 0 k vector. Therefore modulus of a 1 square 0 square 0 square square root 1 equal to 1. So when del dot the directional derivative is nothing but del pi value, del pi is 5i plus 4j plus 3k dot a vector I vector plus 0 j vector plus 0 k vector and then by 1. Therefore I dot I1 other value 0, so the directional derivative 5, I dot I1, j dot 0, k dot, so every term 0, only I dot I1 5. So the option is 5 is a B option. Then direction of 3 comma 1 comma minus 2 is the directional derivative of pi equal to x square y square z power 4 maximum. So here in this point, any other vector, directional derivative other vector is given, using the other vector find the directional derivative. But here is a mention to find the maximum. Maximum means it's enough to find the del pi. Del pi is our maximum value. Therefore del pi equal to I dou by dou x plus j dou by dou y plus k dou by dou z into x square y square z power 4. So when I multiply I into dou by dou x of x square y square z power 4, j vector dou by dou y of x square y square z power 4, k vector dou by dou z of x square y square z power 4. Therefore here now the variable is x and here y is the variable and z is the variable. So when I am differentiating the first term, I vector into 2x and y square z power 4 plus j here x square 2y z power 4 plus k vector x square y square 4 z cube. Now the point del pi at the point 3 1 minus 2, 3 1 minus 2 to substitute. So I vector 2 into 3 and 1 square minus 2 power 4 plus j 2 into 3 square y 1 then minus 2 power 4 and plus k vector 4 into 3 square then 1 square minus 2 cube. So therefore this term 2 power 4, 2 into 2 into 2 into 2, so 16, so 16 into 2, 32, so 32 into 3, 32 into 3, 96 I vector plus this is a 16, 2 into 2, 4, 8, 16, 16 into 2, 32, 32 into 9, so 32 into 9, 8, 28 j vector plus k vector, this is a minus term, therefore minus, so 8 and 4 9, so 8 into 4 32, 32 into 9 288. So when I am taking 96 common, when I am taking 96 common, then I vector plus 96 into 3, therefore 3j vector minus 3k vector, therefore this option is C. Then unit normal is n cap del pi by del pi modulus. So find del pi I dou by dou x of x square y square minus z square plus j dou by dou y of x square y square minus z square minus 1, this minus 1 right hand side value, plus k vector dou by dou z of x square y square z square minus 1. So when I am differentiating, here x variable, here y variable, here z variable, therefore when I am differentiating I vector 2x other term 0 and j vector 2y other term 0 plus k vector 2z other term 0. At the point when I have substituted del pi at 1 1 1, therefore 2 when x 1 2i vector, y 1 2j vector, z 1 2k vector, so 2i vector, j vector, k vector. Then del pi modulus every term square root, so it's 2 square 2 square 2 square, then square root 4 plus 4 plus 4 root 12. This is a 4 into 3 possible, 2 root 3. Therefore, n cap nothing but del pi by del pi modulus. So, del pi value 2 into I vector j vector plus k vector divided by 2 root 3. So, 2 cancel, I vector j vector k vector by root 3. See where is this option? The option, actually this is a minus, I missed it here. Any minus term? Yes, here minus. So this place is minus, I missed minus here. Therefore this is a minus, and here also minus, 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 and plus this is a minus 2 square, so I will have plus, and here minus, this is a minus. So this option is first option, I vector j vector minus k vector by root 3. Then next problem, see f vector given, then check this is a solenoidal or irrotational or constant vector or both solenoidal irrotational. So first of all, to check with this problem, del dot pi, what is the, when it's a solenoidal, solenoidal is nothing but when dot f vector 0 is a solenoidal, irrotational when del cross f vector 0 irrotational. So therefore first find del dot f vector. Del is I into dou by dou x, j into dou by dou y, k into dou by dou z, and dot x plus 3y I vector, y minus 3z j vector, x minus 2z k vector. For here I dot I1 other value 0, first term into first term I dot I, dou by dou x of x plus 3y. Next I dot j 0, I dot k 0 plus j dot I 0, j dot j 1 dou by dou y of y minus 3z plus j dot k 0, k dot I 1 sorry 0, k dot j 0, k dot k 1 dou by dou z of x minus 2z. So when I differentiate with respect to x 1 and plus y is 1 plus z is minus 2, therefore 0, this f vector is solenoidal. Now check it's a possible irrotational. So irrotational is nothing but del cross f vector. So I vector, j vector, k vector, the first term del, therefore dou by dou x, dou by dou y, dou by dou z, the first term x plus 3y, second term y minus 3z, third term x minus 2z. Then this is a determinant. Now I vector, leave this column and row. So now this is a determinant to calculate. How calculate this term, dou by dou y of, so dou by dou y of x minus 2z minus, next this term multiplication, dou by dou z of y minus 3z, this is the first term, and then minus, next to minus term, this is a minus j vector. Again when to leave this column and row, dou by dou x of x minus 2z minus dou by dou z of x plus 3y. So this cross multiplication to leave this column and row, this is a part. Which part? This part, this part, and this part, this part. And third one is k vector. So plus k vector into, leave the column and row, so dou by dou x of y minus 3z minus dou by dou y of x plus 3y. Now when I am differentiate this term, so I vector, dou by dou I means 0, here z minus 3 plus j vector x term 1, so minus j vector. Then when I am differentiating x1, see this is a 1 and here 0, therefore 1, plus k vector y, the first term 0, then minus 3, therefore minus 3i vector minus j vector minus 3k vector. So this is not 0, therefore f vector is not irrotational. When, therefore the option is first option, this problem is solenoidal. And now this problem is f vector given, mention solenoidal, then find the value of lambda. So if f vector is solenoidal, del dot f vector equal to 0, therefore del value is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z dot f vector x plus 3y I vector y minus 2z j vector x plus lambda z k vector equal to 0. So I dot I1, j dot j1, k dot k1, other value 0, therefore dou x of x plus 3y plus dou by dou y of y minus 2z plus dou by dou z of x plus lambda z equal to 0. Now when I differentiate with respect to x, this term x, y, z, z. Therefore the first term, other term 0, 1 plus then lambda equal to 0, 2 plus lambda 0, lambda equal to minus 2. So the lambda value minus 2, the option is B, minus 2. And the next one, irrotational, f vector irrotational, then find the value of A. So when is irrotational, del cross f vector 0, therefore I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. The first term axy minus z cube, second term a minus 2 into x square, and third term 1 minus a into x z square. So determine equal to 0. Therefore I vector into, leave this column and row, therefore dou by dou y of 1 minus a x z square. So when we are differentiating dou by 1 minus x z square, then minus dou by dou z of a minus 2 into x square, then minus j vector, again leave this column and row, therefore dou by dou x of 1 minus a x z square minus dou by dou z of a xy minus z cube plus k vector, again leave the column and row, dou by dou x of a minus 2 into x square minus dou by dou y of a xy minus z cube equal to 0. So the first term variable y, therefore the whole term 0, because here no y variable, all values are constant. Then here a minus 2, this term also 0, so I vector 0 minus 0 minus j vector, here x term, when I am differentiating x, therefore here x only the variable, the term 1 minus a into z square, then dou by dou z, first term 0 minus 3z square, and then plus k vector, dou by dou x of, so 2x a minus 2, and then y term minus ax, other term 0, equal to 0, equal to 0. So therefore now Ax, the term is nothing but Ax. So a1 minus a z square minus 3z square. So multiply with each and every term minus j vector. So z square minus a z square minus 3z square plus k vector 2xa minus 4x minus 4x. Now after this simplification, this term 3z square, when I subtract this, minus j vector minus 2z square minus az square, and then plus k vector subtraction xa minus 2xa minus ax. So xa minus 4x equal to 0. Now compare with this term I vector j vector. So therefore the term is nothing but the right hand side to consider 0 is 0 I vector, 0 j vector, 0 k vector. Compare with the I, j, k. So when I am taking this term, see this term, whole term I am going to take minus when I am taking common out. So therefore this term 2z square plus a z square 0, then 2 plus a z square I am taking out 0, then 2 plus a equal to 0, a equal to minus 2, and then next term xa minus 4x 0, then x I am taking a minus 4 0, then a minus 4 0, a equal to 4. Therefore see a minus 2 4, to check this option minus 2 is not there, so 4 is given, therefore 4. Then next problem, if pi is scalar function, then curl gradient pi is. So gradient pi means curl is nothing but del cross del pi. So del cross del pi value 0. So it's a property. Suppose del cross del pi, you want to show how to solve this. See, this is a I vector. How to solve this? I vector, j vector, k vector. First del, dou by dou x, dou by dou y, dou by dou z. Del pi, dou pi by dou x, dou pi by dou y, dou pi by dou z. This is a determinant. Therefore I vector into, leave the column and row, dou square pi by dou y dou z minus dou square pi by dou y dou z minus j vector. Now again leave this column row, dou square pi by dou x dou z minus dou square pi by dou x dou z plus k vector, leave this column row, dou square pi by dou x dou y minus dou square pi by dou x dou y, to cancel every term, this term to cancel. So therefore the value 0. The option is fourth option D. And then next del cross r vector. So del cross r vector is nothing but del cross r vector. Now r vector is xi vector, yj vector, zk vector. Therefore I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z, r vector x, y, z. Therefore I vector into, leave column and row, dou by dou y of z, dou by dou z of y 0 minus j vector. Again leave this column and row, dou by dou x of z. To expand this detail, so So this term is I vector leave the column and row dou by dou y of z minus dou by dou z of y. This is the first term. Minus j vector leave this column and row dou by dou x of z minus dou by dou y of x, plus k vector dou by dou x of y minus dou by dou y of x, but when the variable comparison 0. So the option is del cross f vector or vector 0. And next a vector is a constant vector and r vector is the position vector and the point xy is z with respect to origin. Now the question is gradient a vector dot r vector. So therefore now see what does it mean. This gradient means del a vector dot r vector. This is a to calculate r vector, xi vector, yj vector, zk vector. Then a vector to consider some constant a1 I vector, a2 j vector, a3 k vector. Now this term I vector dot r vector to calculate first. I vector is a1 I vector, a2 j vector, a3 k vector dot xi vector, yj vector, zk vector. Then I dot I, j dot j, k dot k 1. Therefore this term a1x, a2y, a3z. Therefore del into a vector dot r vector is nothing but I vector dou by dou x of a1x, a2y, a3z plus j vector dou by dou y of a1x, a2y, a3z plus k vector dou by dou z of a1x, a2y, a3z. When I am differentiating with respect to x, the x term, this is the x term, y term, z term. Other values are constant. Therefore here I vector a1, x differentiation 1, other value 0 plus 0 plus j vector, first term 0 constant, second term a2, y differentiation 1, third term 0 plus k vector dou by dou z, a1 x 0 plus 0 plus a3 into 1. So what is the term? a1 I vector, a2 j vector, a3 k vector is nothing but a vector. See the answer, C option, a vector. Now divergence of, if a vector constant vector, r is the position vector and the point origin, divergence of a vector cross r vector. So first to find a vector is nothing but a1 I vector, a2 j vector, a3 k vector, r vector, xi vector, yj vector, zk vector. Therefore a vector cross r vector, I vector, j vector, k vector, a1, a2, a3 and then x, y, z. Therefore the term I vector into, so a2z minus a3y minus j vector a1z minus a3x plus k vector into a1y minus a2x. So now the divergence means del dot a vector cross r vector, I vector by dou x, j vector by dou y, k vector dou by dou z dot the whole term a2z minus a3y into I vector minus a1z minus a3x into j vector and then plus a1y minus a2x into k vector. I dot I1, j dot j1 k dot k1 other value 0, therefore dou by dou x of a2z a3y, then minus dou by dou y of a1z minus a3x plus dou by dou z of a1y minus a2x. So when I am differentiating the term, the first term no x term, no y term, no z term, therefore 0 0 0 equal to 0. Now the answer, first option A, 0. And then if A is a constant vector or vector, the position vector of the point x, y, z with respect to origin, then the curl A cross F vector. Now see here, A cross F vector, we know the answer as usual. A cross F, A vector, A1 I vector, A2 J vector, A3 K vector, then R vector, Xi vector, Yj vector, Zk vector, and then A vector cross R vector, nothing but I into, so this is a value I into I vector into A2z minus A3y, then minus j vector A1z minus A3x plus k vector A1y minus A2x. Therefore curl is nothing but del cross A vector cross R vector. Therefore I vector, j vector, k vector, dou by dou x, dou by dou y, dou by dou z. The first term a2z minus a3y, second term minus when I multiply inside, so minus maybe a3x minus a1z. The next term a1y minus a2x. Now I vector, leave this column and row, dou y of the term a1 minus dou z of the one minus of minus a1 minus j vector. Now leave the column and row, dou by dou x of the term minus a2 and then dou by dou z of the term minus a2 plus k vector, dou by dou x of a3, dou by dou y of minus a3. Therefore this term 2a1 I vector plus 2a2 j vector, 2a3 k vector. So when I am taking 2 common, a1 I vector, a2 j vector, a3 k vector, now 2a vector. So the option is C, answer C, option C, 2a vector. Now the 13th problem, see integral, if the value of integral over a to p f vector dot dr vector does not depend on the curve C but only on the terminal points A and B, then f vector is a call, the value is nothing but the definition, so it's a conservative vector. So conservative definition, this is a one. And the 14th one, see the value of integral over C r vector dot dr vector, then C is the line y equal to x in the xy plane from the point. So therefore integral over C r vector dot dr vector is nothing but r vector, xi vector, yj vector, zk vector, dr vector, dxi vector, dyj vector, dzk vector. Therefore, so when we substituted this point, so integral over 1 to 2, so r vector and here r vector dot dr vector, I dot I1 x dx, j dot j1 y dy and z dz. So this is a x dx, y dy, z dz. Therefore this term x dx, but here only two line, therefore we consider only xy plane, not z plane, just remove this z plane. therefore the given point y equal to x. So when y equal to x, then dy equal to dx. Therefore 1 to 2 x dx plus yx dy dx. Therefore 2 times of 1 to 2 x dx, then 2 times of x square by 2, 1 to 2, 2 cancel, then 2 square 4 minus 1 3. So the option is D 3. The option is D. And then the work done by the conservative force when it move particle around the closed curve is nothing but del cross F. This is a property. And then F vector is given. F vector is given y equal to x square, then the value f vector dot dr vector. Now see, r vector is xi vector, yj vector, zk vector, dr is dxi vector, dyj vector, dzk vector. Therefore here f vector integral over c f vector dot dr vector xy plane, therefore then remove for z part. Therefore integral over the limit 0 to 1 f vector x square I vector y cube j vector dot dxi vector plus dyj vector. So when I multiply these two terms, integral over c 0 to 1 x square dx I dot I1 j dot k 1 j dot j1, so y cube dy. Here the lines given y equal to x square. So when y equal to x square, dy equal to 2x dx. Therefore substitute integral 0 to 1 x square dx plus y x square cube dy 2x dx. Therefore 0 to 1 x square dx plus 2 into x power 6 2 into 3 and 7 dx. When I integrate x cube by 3, 2 into x power 8 by 8, 0 to 1, therefore 1 by 3, 2 by 8. So when I cancel this 1 by 4, 1 by 3 plus 1 by 4, then 4 plus 3, 7 by 12. The option is D, 7 by 12. Now the connection between the line integral, double integral. So line integral, when the double integral, then it's a Stokes theorem, because integral over f dot dr equal to double integral del cross f vector n cap ds. So this is a single and surface. And then connection between surface and volume, double integration equal to triple integration, Cauchy residue theorem. And using Cauchy residue theorem, find the value double integral s r vector ds vector, where r vector is the position vector and v is the volume. Now how to calculate this? See, double integration of f vector dot n cap ds. This is a surface. Now triple integration del dot f vector into dv v. Therefore this term del dot f vector, so what is the value here? Del dot f vector is nothing but r vector, f vector is r vector equal to xi vector, yj vector, zk vector, and then del dot r vector, because r is only given, del dot r vector, not f vector, this is r vector. Okay, this is r vector. Now del dot r vector is dou by dou x of x, dou by dou y of y, dou by dou z of z. Now the value 1 plus 1 plus 1, 3. So this is a triple integration 3 dvv. Therefore 3 I am taking, triple integral dv is nothing but volume. Therefore 3 value. The option is C. And then if S is any closed surface enclosing the volume of V, and if F vector is given, then the value of double integral S into F dot n cap ds vector. Therefore, this term is nothing but double integral S F dot n cap ds equal to triple integration of del dot F vector into dV. Therefore, to find del dot F vector, so del dot F vector is nothing but I into dou by dou x plus j into dou by dou y plus k into dou by dou z dot axi vector by j vector cz k vector. Therefore, dou by dou x of ax, dou by dou y of by, dou by dou z of cz. When differentiating this, a x differentiation 1 plus y differentiation 1b, z differentiation c. Therefore, triple integration of v a plus b plus c dv. So when I am taking a plus b plus c into the volume v, the option is B. Thank you.